Hi everyone, my name is Dr. Peter Bott, and this is the instructional video for using the muscle image quantification software Myotally. Myotally is a user-friendly tool for automated quantification of muscle fiber cross-sectional area and central nucleation. It also has an optional feature for calculating muscle fiber mean fluorescence intensity from immunohistochemical stains. To download the software, first navigate to this URL, which is given in the publication Both et al. Once you're at the GitHub page, scroll down to Assets. The first link will download some sample images that we use to validate the software in our publication. The second link will download a Windows-compatible version of the application, and this link will download a zip file that contains the Mac-compatible version of the software. So after you click on that link to download the zip file, go to your downloads and double click on the zip file to extract the application. And let's move that application to the desktop. Now to open Myotally, right click and click open. And you'll be asked, are you sure you want to open the software? Click open. And this window should show up. Nothing needs to be done with this window. It can just be used to monitor the progress of your quantification once we initiate the quantification. If at any point you want to terminate the application, just exit out of this window and the software will close. So after you click to open Myotally, it will take another 1 or 2 minutes or so before the user interface shows up. So in that time, let's talk about proper folder structuring and image naming. So folders should be structured such that there is one main folder. In this example, the main folder is this one named RFP Images on the desktop. And within that main folder are your image folders. You can have as many image folders as you want inside of the main folder, and they can be named however you want them to. Inside of the image folders are your individual images. All image channels should be separated. Many imaging softwares have a default option to export your images with the image channel separated. I used Velocity to do this. So here you can see we have a DAPI image channel and a laminin image channel and an RFP image channel, which we will use to demonstrate the mean fluorescence intensity calculations. So these images can be, these channels can be named whatever you want to name them. These are just the default names that are given by Velocity when I exported them, but you can name them whatever you want. It's just important that the naming is consistent across all of your image folders. As you can see, the DAPI image channel is named the same thing in all 3 of our image folders. We recommend using a lossless compression format like .tiff. Myotally is compatible with JPEG and PNG and other lower quality image formats, but for the sake of image quality, we recommend using a image format that does not result in loss of metadata like a .tiff format. So now that the user interface is opened, let's start putting in the user data that the software needs to run the quantification. The first thing that it asks for is this folder path. Now to get the folder path on Macs, you go to the folder that you're interested in, and you can do right-click and Option. On Windows, it's right-click and Shift, and go down to Copy as Path Name. On Windows, it'll be Copy as Path. So let's copy that path name and just paste it into the folder path. And now let's go through and copy and paste in all of the names of the channels that we're interested in quantifying. So first is the DAPI image channel name. And make sure you include the file extension. Now the laminin image channel name. Oh, that's this one. And the name of the image channel for your MFI quantification. The next information to enter is the image quality. If you have images that are focused well with no staining artifacts and your staining is robust and your tissue integrity is good, you can use the high image quality setting. If you have images that are maybe a little bit more blurry in some areas, or if the staining is not so robust, or if your tissue integrity is kind of poor and broken, you can use the low image quality setting to improve myofiber segmentation. Next, you can put in the range of muscle fiber sizes from minimum to maximum. For this example, I'm going to use 200 to 6,000, but we determined this range empirically for cross sections of mouse TA muscles, and whatever muscle you might be using could have a different range, and I recommend determining this range empirically. But this would be a good starting range for trial and error if you want to start out with this, and look and see if maybe if you're missing some smaller fibers or if you're missing some larger fibers, you can adjust this size range accordingly. The next input that the user interface asks for is the pixel to square micron ratio. The default is 1, but you should change that to whatever the actual pixel to micron ratio is for your images. So once we've put in all of this information, let's click Run Myotally, and the software will immediately start processing the images in your image folders. And we can see here there's activity going on in this folder. And if we look at our monitoring window, the name of the image channel that is currently the name of the image folder that is currently being processed shows up on the bottom line. And once the image completes processing, it'll move on automatically to the next image folder, and then that image folder will show up in the bottom line. So processing takes about 1 or 2 minutes, maybe 3 minutes for good quality images. For lower quality images, if you use the low image quality setting, it might take a little bit closer to 5 or 6 minutes. And this is for a single 10x image field with a 1-to-1 pixel to micron ratio. So see there, it's completed the first image folder and it's moved on to the next image folder. The first output data that we're going to look at is this TIFF file that's generated. It's called final.tiff, and you'll see it's an overlay of your laminin stain with your DAPI stain, in which all of the fibers that are segmented are circled in white or in green, and they're also numbered. Fibers circled in white contain centralized nuclei, and the fibers circled in green have no centralized nuclei. And this image can be used to check for proper segmentation of your fibers. So some quantitative outputs will show up in the results folder. For each image folder that is processed, a .text file will appear that has the same name as that image folder. So in this case, injured RFP 24_1 corresponds to this folder with the same name. It also has a timestamp after the name. So let's double click on that to open it. And you'll see 4 columns of data. The first column is an enumerated list of all of the fibers in the image, and the numbers in this list correspond to the numbers that are inscribed in the fibers on the final.tiff image that I showed you just a minute ago. So there's this column of fiber numbers, and there's a column of cross-sectional areas. For each muscle fiber number has a corresponding cross-sectional area and a centrally nucleated fiber status. 1 or 0 corresponds to yes or no for centralized nuclei. And there's also a column for the mean fluorescence intensity that corresponds to that fiber. See, our software has already finished processing those 3 folders, so it doesn't take long at all. So in addition to these text files that contain the 4 columns of data, there are 2 folders that contain CSV files. And each image folder will have a CSV file for cross-sectional areas and mean fluorescence intensities. And if you open this, you'll see there's a comma-separated list of all of the cross-sectional areas for all of the fibers that are segmented in this image. So this is useful for copying and pasting bulk data into graphing software such as GraphPad. And we have the same type of text files for the mean fluorescence intensities, as you can see here. So that's it. It's pretty user-friendly. It's easy to use. You don't need to have a lot of experience. If you have any trouble, please reach out and we can help you. We'll be happy to help you. We hope that this expedites your pace of research, and if you use Myotally, please cite us at Both et al. Thank you.